Hi, welcome to the next lesson. We're going to be dealing with quadrilaterals and in that section, parallelograms. The objective is how do we use properties of parallelograms to solve problems? Before we go in depth with it, we need to know the definition. So the definition of a parallelogram is a quadrilateral with both pairs of opposite sides that are parallel. So AD is parallel to BC and AB is parallel to DC. We're going to learn characteristics that you'll find in a parallelogram. So the first one says that opposite sides are congruent. So with the example on the right, it asks us to solve for x and y. We have all the sides, some with numbers and some with variables with numbers. So based on the characteristics that we learned, we know that the opposite sides are congruent. So if the opposite sides are congruent, then that means they're equal to each other. So for the first side, we're going to set it equal to each other. 30x equals 150. We solve for x and we get 5. And then for y, we notice that we have 2y on the top and 72x on the bottom. We can set them equal to each other, but the thing is we have to plug in one of them in order to solve for the other. We already found that x was 5. So we're going to plug it into 72x and then get 360. Now we can set it equal to 2y and then solve for y, which will come out to 180. Okay. Then second characteristic and the third, the second says opposite angles are congruent. And then consecutive angles are supplementary. So supplementary means, and I'm going to write it because you already came across it before, it means 180 degrees. So we're going to solve for x and y based on those two characteristics. So we have a quadrilateral and we have 3 out of the 4 sides of 3 out of the 4 angles with measurements that we need to solve for. So based on the opposite sides, we know that it's congruent. And we know that consecutive angles are supplementary. That means you have to take the 2 angles and add up to 180. So seeing how this one is 3y and the other one is 12x, we can't solve, we can't set it equal. We can set it equal to each other, but then we are left with 2 unknown variables. So let's go for this consecutive angles, 6x and 12x. We knew that if we add them together, it has to equal 180. So 6x plus 12x equals 180. Combine and then solve, we get x to be 10. Now we can plug in that 10 to one of either 6x or 12x and then set it equal to 3y. So I set it equal to 12x. I already found x, plug it in, then I get 120. Now I can solve for y and end up with 40. And the last characteristic of a parallelogram is that if one parallelogram has one right angle, then it has 4 right angles. So for this one, we're solving for x and y. We see the little angle marker that tells us that it's 90 degrees. And now we can solve for the others, because if we have at least one right angle, then the others are also going to be 90. So I'm going to solve for 3x, for x. So I'm going to set that equal to 90. And then solve for x, it gives me 30. And then next I'm going to solve for y. So 4y equals 90. And it'll give me 22.5 for y. Okay, so just a recap of the characteristics. It says if a quadrilateral is a parallelogram, then the opposite sides are congruent, the opposite angles are congruent, the consecutive angles are supplementary, that means it adds up to 180, and if a parallelogram has one right angle, then that means all the others are right angles too, so there'd be 4 right angles. Okay, now we're going to deal with the diagonals of parallelogram. So if in a parallelogram, one diagonal forms 2 congruent triangles. So we just highlight the triangles. So this one will be in green. So we have this triangle, ADC, and then the other one will be ABC. So two congruent triangles. And in symbol form, we will have triangle ADC is congruent to triangle CBA. And the second thing with diagonals is that if you have two diagonals, as you see in the diagram, then they bisect each other. So that I will mark to show. So we have US, so that means RT is bisecting US into two congruent segments, and then US is bisecting, get that, is bisecting RT, so RQ and QT are congruent to each other. Alright, so then in symbol form, we can say that UQ is congruent to SQ and RQ is congruent to TQ. So again, just to recap for the diagonals of a parallelogram, if you have one diagonal, then it's going to create two congruent triangles. If you have two diagonals, they're basically bisecting each other. Alright, so we're going to do problems, practice problems based on the properties of diagonals in a parallelogram and the characteristics. So the first one, they gave us our information. So this side, actually, I will label it with letters. So we got we got a quadrilateral. Well, it's a parallelogram, ABCD, and then the center is E. And then they gave us 4y. EB is 4y, EA is 3x, DE is 8, and then EC is 12. So, based on the information that we know about the characteristics, okay, so let's do the first one. So we're setting 3x equal to 12 because we have two diagonals and we know that they're bisecting each other. So with that, this is going to be congruent to this. So AE congruent to EC, and then we have DE congruent to EB. Alright, so now I set 3x equal to 12. Now I'm going to solve for x. So that will give me 4. So x equals 4. And I notice that DED and BE are congruent, so then I'm going to set 8 equal to 4y, and then solve for y, which gives me 2. Make this. So there you go. Again, we're basing it off about the two diagonals in a parallelogram. They bisect each other, so whatever segment values they have or information, you set it equal and then solve. Alright, let's go on to the next one. So we have a parallelogram, and again, it has the two diagonals, and we notice that there's a right angle in one of the triangles. So the first thing we need to do, well, let's see. We know that, and I'm going to just mark those up first based on what I know about the diagonals. So I know that ED is congruent to EB, and we have AE congruent to EC. Alright, so I think with that, and then I'm going to just label based on what is congruent. So I know that DE, this part is 4, and then AE is going to be Y because EC is Y. Alright, and I know from the characteristics in the parallelogram, the opposite sides are congruent. So I'm going to put this in red. So this is 17. This is also 17. This is X. So I'm just going to put X and then find out what is going on with that one. All right. So let's do this. So the first part, we already said that DB is congruent to BE, so then DE is also 4. And X is equal to 17. So I'm going to label that as 17. So this will be 17. This is also 17. All right, next one. Since we got that information and we have this right triangle, it may not look like it, but if you have that angle there and it's a 90-degree angle, then it is a right angle. So I'm draw a diagram. I got 17 for AD, DE is 4. So now I just have to solve for EA. EA, since it's Y, it's the same, it's going to be congruent to EC, then I'll solve it. Not only I'm going to solve for AE, but I'm going to solve for Y also. So I plug it into the Pythagorean theorem, and AE is my hypotenuse because it's opposite the 90-degree angle. Solve it, and I just rounded off to 17.5 because I can't find a simplest radical form since I get two prime numbers. So I just leave it at 17.5. And then that is equivalent to EC, which is what we're solving for Y. So 17.5 for Y. Okay, and let's go on to the last one. So this is also a parallelogram. So again, I'm going to put every information I know about the characteristics and the diagonal. So with the diagonal, I know that DE is congruent to EB, and AE is congruent to EC. Okay, I know the sides, opposite sides are congruent. So I'm going to make that, so this will be 1, 2, 3. And then this side, I'm going to this side. And I notice there's a right angle there, an A, so DAE is a right angle. All right, so I noticed I made a diagram showing that little triangle that I'm going to work with. I see that this is 12. It's 12, so I put 12. And then this one's 3x. So angle E is 3x. And what else did I put? So I noticed that there's two angles here. This angle in 3x and then the other one in ADE is also the same. So that means they're congruent. So they have the same mark, they're congruent. So because they are congruent, I go back to what I know about triangles. When you have congruent base angles, then that means the side angles are going to be congruent, and that's for isosceles triangle. So that's why I made AD 12, because if the base angles are congruent, then their sides are, the opposite sides are also congruent. So I have two sides. Now I can look for ED, and I just put that ED is equal to, angle E is equal to angle D. So then if angle E is 3x, then angle D is also 3x. Now I can actually solve for the sides, because I know this is a right angle. Well, first I'm going to solve for the angles. I know that this is a right angle, that's going to be 90. So then I'm going to just double these two, 3x and 3x, so 3x plus 3x, so 2 times 3x plus 90 equals 180. And then I solve for x, which is 15. Now my next step is I'm going to solve for ED, because I already found x, now I need to find y. And I know that DE is congruent to EB. So I'm going to solve for y for that side, and then I'm going to set it equal to 2y so I can find y. So I use the Pythagorean theorem, plug in EA and AD are my legs, ED is the hypotenuse, so that's what I'm looking for. It's opposite the 90-degree angle. I find it to be square root of 288, but I can break it down further. into the factors of 144 and 2. 144 gives me a perfect square of 12. 2 is a prime. It stands underneath the radical. So I found ED. Now, take ED, knowing that it's congruent to BE, set it equal to each other, and then solve for y, which gives me 6 radical 2. And there it is. I got my y, which I will box in red. And that's it. So you're basically using the information, the characteristics about a parallelogram, and the information, the properties of the diagonal in a parallelogram, and also a little bit of triangles, right triangles, the Pythagorean theorem, all that stuff, and it all into this shape in order to find the missing variables. So, okay, so we've reached the end. Just a recap of what we've learned. We learned about parallelogram, which is a quadrilateral with opposite sides that are parallel. That's one of the characteristics of a parallelogram, so the opposite sides are parallel. We also learned that the opposite sides are congruent. The opposite angles are congruent. Consecutive angles, that's mean one next to each other, one after another. When you add them up, they're going to be supplementary, that's 180. If you have one right angle in that parallelogram, then all the others are right angles. So there's 4 right angles. You also learned about the diagonals. If there's one that is formed, and it's going to create 2 congruent triangles. If you have 2 diagonals, they're bisecting each other. And all of those characteristics and properties put together, you can find missing pieces in that parallelogram. And that's all. Right, so, if you are confused, you can ask any questions, email, and I can help you out with steps and examples and all that stuff. So we've reached the end of the lesson, and have a good day.